Good afternoon, everyone. I do see we've got slightly less numbers than this morning. I'm assuming that most of you are attending Mr. Cottrell's lectures and you think it's not necessary to attend my lectures. If you are struggling, I do recommend that you attend both. We've got different ways in which we present the content. So I guess looking at both of us for the first 1 or 2 or 3 weeks would be good until you see where you are. I am still here. Why did my sound vanish for a moment? Okay, so let's maybe just have a test. If someone can't hear me, just kind of either raise your hand or just type yes in the chat. Okay, so I think it's just your instance that can't get my sound because I have about 4 confirmations. Right, 5 confirmations, 6 confirmations. Okay, that's okay. I have confirmed that you can hear me now. So we can maybe discuss the Fibonacci code when we talk about the design, but let's first get into today's tutorial before we discuss the practical. So I will give you enough time to ask questions about the practical afterwards, but I think for now, let's focus on the examples that I have for you, and then after we're done with the examples, if you have any questions relating to the practical, then you can ask them there. That way we have more of a guided, I wouldn't say guided tour, but more of a guide for the lecture. Right. So before I start, I'll handle this one last question. See, you've got your hand up. Do you have a question for me? And there is no comment. Right. So one thing, if you are going to raise your hand, okay, it's fine if it's a mistake. If you are going to raise your hand, that's an indication that you want to use the audio. If you have a question and you're going to type it out, please just type it out. But if you raise your hand, that means you want to use the audio. Please keep that in mind. Otherwise, we're going to kind of have a wait and a delay, and it just waste your time. All right. So let's get started with today. So today we're going to be covering recursion in the tutorial. So we've got 2 examples for you to kind of help you get used to the concept of recursion. And hopefully after this, you'll be more comfortable with recursion. One thing I can tell you, recursion, having seen it for the first time, it can be confusing. You have to code it out yourself for the time to really see what's going on. Just seeing what's going to happen and seeing how the functions call one another doesn't actually allow you to understand it perfectly. But once you code it out yourself and actually see what's going on and play around with it slightly, you'll kind of start getting used to the fact that you need a base case, you need a recursive call, and you need to make sure that the base case addresses a value in the recursive call itself. But let's get started, and then you'll understand what I mean in a moment. So, establishing what a recursive method calculates, and the first thing you need to do is understand what is a recursive function. So recursive functions are a class of functions on the natural number studied in compatibility theory. Now, you don't have to know exactly what compatibility theory is, but basically it's the theory of things that work well together. There's an entire theory set on what compatibility theory is and how it works, but we won't go into too much detail there. What is important is a recursive functions. So recursive functions take their name from the process of recursion, by which the value of the function is defined by the application of the same function applied to a smaller argument. So the idea here is you take the function, you will apply a formula inside that function, and then as the function calls itself, it will become a smaller and smaller subset or argument of itself. Now, that is true in some cases, depending on how you approach the recursive call. But essentially, you're breaking up the recursion into smaller parts. So we do have an example for you, and a factorial is one of those examples. So consider the familiar factorial function, x with an exclamation mark at the back. So the function returns the product of 1 times 2 times 3 until the nth number, or in this case, number x. And then if x is larger than 0, it will continue. And if x is larger than 1, it will also continue. The idea about x being larger than 0 identifies our first base case. It's not clearly defined in that second bullet point, but in the recursive definition, it shows you the base case. So you've got a base case of factorial of 0 will equal 1. So the idea there is with the factorial, you will have, when it reaches factorial of 0, it will be equal to 1. And the formula, or the function definition, is factorial x plus 1 equals x plus 1 times factorial of x, identifying the fact that there is 1 is being subtracted from the equation every single time it calls the function. Now, looking at it, hearing it, it might be slightly confusing how I'm describing it, but looking at a example of how the function would operate is if you have factorial of 4, it is basically you return the value 4 times factorial of 3. And then that will continue until it reaches a base case of factorial of 4. After which, once you have that integer value and you don't have a recursive function anymore, it starts returning all the values until it reaches the initial call, after which you have a final value being calculated. Now, just seeing it like this doesn't always help you. So let's actually look at what the code would look like. So if we have to code this out, if we have to code out a factorial function, and we look at how it is approached, you first initiate your function or create your function. So I just made it fact instead of writing out factorial in a full sentence. You've got a value being given, which is the value that we want. So that will identify the x before the exclamation mark, and our return will be an integer. Now, there's a few things you need to address here. With factorials, when you multiply two negatives, you get a positive. So the idea here would be is before you send a value into this function, you'll probably apply an absolute function to that value, ensuring that you have the positive result of your multiplication. So that's just one thing to keep in mind. Now, the first thing we do is we address the base case. Now, can everybody else hear me clearly? Because it seems like it might just be your sound. Okay, so it seems it's just your sound, because everybody else hears me. Okay. So, well, you can't hear me, so I probably need to type in. I hear sound in the background. Is there someone with a question? Someone activated their mic. Do you have a question? It's the person that can't hear me. Okay. Still can't hear me. I'm muting your mic. And I think I just accidentally removed you from the session. Please just make sure that you don't accidentally activate your mic. All right, so in any case, so looking at the function, you see you've got a private function factorial, you've got the number you want to calculate, so that will identify the number before your exclamation mark, identifying the function. You've got your base case that has been identified. So if x equals 0, then you have a return of 1. Now, why we do x equals 0, not x equal to or less than 0, is because we've got an integer value. And because it's multiplication, you'll ideally work with positive values here. And if you look at factorials, the factorial is generally used as a positive value. You don't work with negative values in a factorial, and if there is a negative, it's generally a negative, open bracket, your function, close bracket, identifying that the negative is only applied after the function has fully executed. So in this case, you'll never get a value, or you shouldn't get a value that is less than x. That's one thing to keep in mind. You always need to keep in mind your base case, but you also need to keep in mind of how the base case will apply to your value, because you want to avoid infinite loops at all costs. And I will code out this after we've run through the two exercises, and we'll look at how easy it is to create an infinite loop if you don't focus on what you are doing. Now, once again, it's not always just about focus, but you can overlook something very easily, create an infinite loop, as we saw earlier today as well. All right, so once you've addressed the base case, then you can start addressing the function, and the function here is unless x equals 1, you basically just multiply with the value of x, and then call factorial of x minus 1, identifying the next value. So in this case, we're working from the maximum value going down to the minimum value. So if we have x as, let's say x is 4, we start with the value of 4. So in this case, when we call factorial of 4, the idea is that we want to return the value of 4 times factorial of 3, which means 4 times factorial of x minus 1, which means the x being 4, we will now have 3. So with it calling itself, it goes through the function again. So it goes to the next function. So it's been called once, and now inside that function, it's calling factorial of 3. So factorial of 3, once again, not reaching the base case, we'll call the function again. So it's 3 times factorial of 2. And then going into that function again and again until we reach the base case. Now the base case is factorial of 0, which means we've got our base case now, and the base case only returns a 1. So what now? Now we return a 1. So what happens is, because we've been calling the function has returned. So now the function will start returning those values. So for the last factorial of 0, it now returns that 1. And now we've got the original x times factorial of 0, which returns the 1. So we've got return 1 times 1. We've got return 2 times 1 times 1, 3 times 2 times 1 times 1, and then finally the last case, which returns our 4 times 3 times 2 times 1 times 1, which gives us a final result of 24. Now, this way of going back, returning the values, this is what makes a recursive function so useful, because you get to get those values back. Now, you're probably thinking, okay, I could have done this easier using a for loop and just saying, okay, we go for int equals we'll code it out, but for I equals 1 to 4, and we just keep on multiplying the value minus the next value, multiplied by the next value, and then we'll get the same result. Yes, you can, but in some cases, recursion, as with Fibonacci, is easier done with a recursive function than with a for loop. There's less management, and we'll code out the recursive function so that you can see what's going to happen if you go with a for loop. and then we'll look at the recursive function itself. So we'll compare the recursive to the iteration, and then you can decide which one would be easier for you. In some cases, you might be more comfortable with the for loop, but the recursive function will be the more correct solution. Once again, with the recursive function, most recursive functions can be done iteratively as well. It just depends on how you want to approach the question, and sometimes recursion is a lot easier, especially when you get to data structures. Some data structures require you to use a recursive function. Yes, you can reverse the order. So we'll go through that when we code it out in a moment, so that you can see that you can approach it from both sides. Because I actually discussed that with Mr. Cottrell this morning. We're showing you it from the last value in terms of calculating it based on the maximum value. And some of you are thinking in terms of the base value increasing from that base value. So we'll look at both of those scenarios in a moment. All right. So regarding the factorial function, are there any questions regarding that specific function? Now, we will code it out in a moment, so you can see what it's going to look like if you code it out, and you can see how the function can potentially return the value for us as well. But are there any questions regarding the recursion method we used here? Okay, so it seems everybody is happy for now. So, moving on to the Fibonacci sequence. So, the Fibonacci sequence is one of the most famous formulas in mathematics. It's a very nice formula or sequence to show the golden ratio, and the center column over here shows you what the golden ratio looks like. It's a formula that is applied in nature, it's applied in biology, it's applied in advertising and design and architecture, not always intentionally, but a lot of the times when you look at how nature operates, you'll see that the formula can be applied there as well. The flowers, leaves, you've got the shell, I believe that's a snail. I'm not 100% sure there. You've got a hurricane over here, you've got the DNA strand over there, you've got a galaxy over there, and you can kind of see that pattern occurring almost everywhere. So, looking at the code for this, the idea of the Fibonacci code is you have two base cases. So your first base case is x equals 0 will return the value of 0, and x equal 1 will return the value of 1. So those are two known base cases, and the reason for that is if you apply the Fibonacci code from the first sequence is the sequence outside of the base case, because if you apply it from x equals 0, it actually will not work. And we'll run through that in a second as well. Then, if you don't have the two base cases, you simply return Fibonacci x minus 1 plus Fibonacci x minus 2. This is one way of looking at it. The other way of looking at it is Fibonacci, if I can just add comment field. So essentially, we look at the Fibonacci sequence code. Let's do that. Fibonacci is essentially x, y, if that is the sequence, and then the next sequence, z, is equals x plus y. If you want to calculate it outright. So that will continue. So if you think in terms of how the function operates, base case 0 and base case 1 is your first two values. So let's apply that with the two base cases. If you do that, you'll see that 0 plus 1 equals 1. All right? 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 8 equals 3 plus 5 equals 8. And 5 plus 8 equals 13, and so on and so forth. So that is the Fibonacci sequence, and that is how it grows. But with our sequence, what we do is we look at the iteration we want and we build it from the last value. So if we want the fourth iteration, we start building it from that iteration, and this formula will give that for us in terms of recursion. But I'll show you another way to do that. So can you zoom that? So these slides are on Eve. I'm assuming you're referring. Sorry, I'm assuming you're referring to the sequence out down here. Let's see. I don't use Adobe's. Well, I'll show you the sequence in a moment again. So you'll see what happens in a second. All right. So we'll code out this in a second as well. So then I'll zoom in so you can see the sequence in a bit more detail. And it is recorded, so you can go and code this out yourself and see how it works. So let's look at Fibonacci 4. So what this does, it calculates Fibonacci until the fourth sequence or the fourth iteration. So what happens? We call Fibonacci of 4, and we determine if one of the two base cases are being identified. No, they are not. So what do? We return Fibonacci of x minus 1 and Fibonacci of x minus 2. So in this case, we've got Fibonacci of 3 plus Fibonacci of 2. Now remember, we're working with a sequential coding structure. Essentially, the function will execute as it is seen, referring to the fact that this function will execute before that function executes. So when we go into this function, everything inside that function will calculate or be calculated first before we get to the second function. And that is something you need to be aware of. And I'm showing you or explaining this to you now, but you'll only fully understand really why that is useful when you start working with specific data structures in your second and your third year. So what happens? Fibonacci of 4 returns Fibonacci of 3 plus Fibonacci of 2. So Fibonacci of 3 gets called first. Fibonacci of 3 returns Fibonacci of 2 and Fibonacci of 1, which, if it is broken down, once again, looking at the left-hand side first, we've got Fibonacci of 2, which returns Fibonacci of 1 and Fibonacci of 0. Now, those two values identify our base cases. So Fibonacci of 1 will simply just return 1 because it identifies our base case. Fibonacci of 0, also a base case, so that returns 0. And then when it comes back to Fibonacci of 2, the return is 1 plus 0. So when that goes back up to Fibonacci of 3, where it was called, we've got that left side that equals to 1. And now we can go to the right side, which Fibonacci of 1 is simply just 1. Going back up, we've got 1 plus 1. All right. Then from there, going back up to our first call of Fibonacci of 4, you can see that now we have completed the left-hand side. Now we can go to the right-hand side and calculate that side. So we've got Fibonacci of 1 and Fibonacci of 0, doing the same steps going in there, returning, and finally getting a result of Fibonacci of 2 plus 1, giving us 3. So if we look at the sequence as we calculated or said it was a moment ago, Fibonacci starts with, this should be looking, oh, there's the increase. Let's just increase this. Okay, so the Fibonacci sequence starts with 0, then 1, then 1, then 2, and then 3. So if we look at this, we've got term 0, term 1, term 2, term 3, and term 4. And Fibonacci of 4 is 3. So that is how you would look at this. Now, there was a question about how would you design this. Now, designing this is, in terms of how you approach your designs, are slightly different. Because let's look in terms of input and output. So now I need to get a clean page here. Let's do this in Word. Right. So you have your design. You've got input, you've got output. You can give me the rest. You can remember the template. I think I have all of them. We've got 7 here. So let's look at input. So let's say we're doing this for, I said code, but that should be algorithm. What is the input for Fibonacci? Let's say we're only doing a program to calculate Fibonacci. What's the input here? Someone says the base case. Now keep in mind the base case is part of the algorithm. So for a recursive call or a recursive function to exist, you need 2 things. One is the base case and one is the recursive call. Now, is the base case input? No, it is not. So the base case in this point, or at this point, the Fibonacci sequence is given to you. So you are told to calculate f of n is f of n minus 1 plus f of n minus 2. And then you are told that f of 0 equals 0 and f of 1 equals 1. So you are given that as a base case, and you're given the formula to calculate f of n. So the algorithm technically is already given to you, or the formula is given to you. But with input, what is input? So if we look at just the formula, we assume that n is input. Now, depending on how you're going to calculate your Fibonacci code, n can either be the nth term, or it can be the max value you want to achieve. It just depends on what the application wants from you. In terms of practical 2, you are told that you want a specific sequence. So for the first 2 sequences, there are no inputs because you're given the values. You're just told to go and calculate the sum of those values, essentially. And then for the second one, if we look at what the third sequence wanted, let's just see. Was prac no, it was prac 2. So it tells you create another button to calculate the parent sequence until the nth term. So your input here would be that nth term. So your input at this point is only that nth term you want to calculate. And then the output would be, in terms of prac 2, would be the sum of the first sequence I'm just going to say sequence 1, the sum of sequence 2, and then the nth term, or the sequence until the nth term, depending on how you interpreted the question. Actions and events, you'll most likely have a button to calculate each one of those separately. You could potentially put those two in one button and then separate the functions, but ideally you would have 3 buttons. You've got your variables, which I'm not going to give you all the answers, so you do have to do some guesswork there. An interface, which in this case is kind of up to you, depending on how you want to display it. For my code sequence, I'm going to be using a rich text editor. I'm not sure if you have used a rich text editor before. You will use it later on this semester. I'm just not sure if you've used it in your 1A as of yet. I know you've been using the grid, but in the case of the Fibonacci code, how I'm going to show it to you is using a rich text box. Sorry, not a rich text editor, rich text box. Then you've got your algorithm, which is your pseudocode, and then your test data, which in this case, the only test data you really have is until the nth value. So you can have the nth value being 0, the nth value being 1, 2, 3, and 4. Ideally, it should be values where you know what the result will be or should be, so that you can test whether your algorithms are working correctly or not. So I'm hoping that is clear up to there. So the design for this one, it's not as clean. Oh, I shouldn't say clean, but it's not as clear as all the other designs. We have a clear, this is what the interface, this is the variables, this is the algorithm, this is the input. Here it's kind of, it's more up to you. It's more about how you interpreted the question. So that being said, let's get down to our code. So like I said, I pre-coded the Fibonacci code. So let's just go and look at the code over here. As you can see, we have it coded out as with the slides. Let's not give away too many secrets up there. So you've got your 2 base cases that test whether the base cases are achieved, and then you've got the formula. So let's go and look how this works. So there is one thing I want to change. I'm just going to change it on this side so you don't see what I'm doing. Like I said, I can't give all my secrets away. Let's just create another button so we can test this out. Yes, I'll zoom in a moment here. I'm just quickly adding a button. And then we are going to show you sorry, I'm displaying the sequence, but I don't want to give away the secret to how I'm calculating the sequence just yet. I'm just quickly adding an input box here so that we can input the nth term that we want. but I can show you there's more than one way to go calculate it. Okay, that should be fine, that should be fine, that should be fine. Okay. Just move this. Sorry, I know you're not seeing what I'm doing right now. I just don't want to give away how I'm going to display this yet, because I want you to go and figure out how to do it yourself. It also depends on how you calculate your function. So, what I did essentially is I just created a function that will give us an input box. The input box will ask us for the nth term. So let's say we want until term 4. Hit OK, and we can see the output is 0, 1, 1, 2, and 3. So every time we execute this, it will calculate until the nth term, showing us every time it increases up until where the nth term calculated. Now, one thing to keep in mind, I just want to see if I have this all enabled. Keep in mind that a recursive function is a continuous call on itself. So every time you increase the sequence, it will also increase the time it takes to calculate it. So this first button that I coded is basically just calculating Fibonacci for a number of iterations. So the first one, I know the text might be small on some of your screens, so I'm just going to read it out to you. So the first one is until the 0 term, the first term, second term, the third term, the fourth term, and every time I click enter, it just calculates the next sequence. But you'll see that as we continue, eventually it will start getting slower and slower to calculate each one of these sequences. And this is where you start seeing it gets slower and slower. So as the numbers get larger at the back, just keep in mind that it needs to iterate through these sequences. And if we look at the function, so Fibonacci 34, you're essentially making more than 34 individual calls back to the Fibonacci code. Now, that is all nicely said. We've got the lecture slides for it. We've got the code templates for it. But you're probably thinking, how are you truly approaching this? So let's look at calculating the Fibonacci code and displaying it. I think that is what you guys really want. So before we continue, are there any questions so far? Is everybody still with me? Are there any confusions right now? If you are confused about something, please do point it out. Not for the Fibonacci code. So for the sorry, not the Fibonacci code, not for recursion. So for Prac 2, you don't need to use the UJ grid. All right, so you guys seem very quiet. Okay, so what I'm going to do now is we're going to code the Fibonacci code in a slightly different way. And we're basically going to increase. What are you using to display? You guys really want to know how I display the Fibonacci code, don't you? Now, I'm not going to give you the answer to how I display this one. That's going to be my secret. Or unless your pause game is on point, I did kind of accidentally show it slightly earlier. But I'm going to show you something else. So let's go and create let's call it a subroutine. make it a private subroutine. So I asked if we are using a template you gave us on E for the practical. So we would like you to use that template as a guideline. You don't have to use that template specifically, but that is the heading or the order in which we would prefer. If I remember correctly, it's input, it's output, it's actions and events, variables, interfaces, test data, and then algorithms. We just gave you the template for those that just want the headings when they start typing it out. But if you're doing it on paper, you can write it down. It doesn't have to be specifically that template, as long as you just have all the headings there. It's just basically a template to remind you of what you have to have in the design. So let's go and create our function and see what we get. Now, to calculate the Fibonacci code, you need 3 things. Remember that. You need the base case. Well, for the Fibonacci, you have the 2 base cases, and you've got the recursive call. Now, how you calculate the Fibonacci code is you take the first value, let's call it x. So if you look at the file itself, or the sequence, you've got x, you've got y, and you've got z. So x being our term 0, y being our term 1, and z being term 1 plus, well, essentially being x plus y. And that will continue indefinitely, or until you tap the top. So if we consider this in a for loop, we continuously swap all the values out. So let's create our function here. And I'm going to use a byref function here. So let's just add another button here. We'll take it from there. So we have a result. And this result, shall we say, are we going to make that our maximum value, or are we going to make that our term? What do you guys want to see? Okay, so let's make this our max. So let's call this our, let's make this max value. So we're going to calculate the Fibonacci code until we hit that max value. So we'll calculate to the closest value below the max value, or if it's equal to the max value. So how do we do that? So the first thing we want is we want to create our call. So we can either go, we can either use a byref, which means we will have term x. So let's just create these. So it will be term x, which is our first term. We have term y, which is our second term. And we have x equals 0 and y equals 1, having those two as our first 2 terms. Now for the Fibonacci code, we will have our term 1. So we're going to start with the first term and the second term and have our max value. Now, when we code this out, you've got x as integer, y as integer, and our max as integer. For this max, is this max going to be a by_ref value, or is this a by_val value? What do you guys think? Okay, so I have people saying by_ref. Think about it very carefully before just looking at it. Are we going to use that max value? Is it something that's going to change or display somewhere? Or is it just a value that we need to pass along? Now, in this instance, if we did something over here, if we calculated something here that, let's say, max value was going to be x plus xy. Sorry, this is just max. Let's say max, so the max value is equal to x plus y. And we want to use the value down here. Sorry. What would happen is essentially, because we want to use that value is being changed up there, but down here, if you want to display it, let's just say message box, we can essentially display max value. So what's happening is you're basically sending this variable into that parameter so it can be altered here, changed here, and then when you return to your original function or button or wherever you declared that variable, you can still continue using the value that was altered inside your function. That's essentially what by_ref is doing. So by reference, it actually sends the original variable in the parameter. So you're changing the original value. So when you use that value again, it changes the value is essentially changed, or however you altered it. That's the difference between by_ref and by_val. If you do by_val, if you want to return a value, it means that you have to actively return the value from the function back into the system, which means you would have max value equals to your function, and then your function would have a return. Just as a quick guide for you to see what's going on there. Right. So this is not by_ref because we're not going to need that value down here again. Yes. So by_val is essentially a copy. So when you send this, it's a copy of those variables. So if you change those values up here, it doesn't change down here. So if I say down here, if I go x equals 5 and y equals 6, if I use x down here, sorry, I'm messing up here now. If I use x down here, x plus max value equals x plus y, max value in this case will be 1 because it will use these values because those values are only available in that subroutine because they are by val. If they were by ref, then the result would be 5 plus 6 down here. I'm hoping that makes it clear. Right, so there is a question. And let me just put my headset on. Okay. The person that has his or her hand raised, you have a question? Okay, so I've got a request to repeat that. I think what I will do is I'll set up a small program as an example. So I think, I'm not sure if we have enough time on Thursday, either Thursday or next week, Tuesday. I'll release a small VB program just to show you the difference between BioRef and BioVal, so that you can kind of see where it is applicable and why we would want to use it. So we can have a small tutorial just that term specifically. Right, but let's get back to our Fibonacci cut. So the reason why we're doing this now is we want to output our sequence of Fibonacci until we reach the max value. But given our two base cases, we already know we've got Fibonacci of 0 and Fibonacci of 1, which is Fibonacci of 0 is 0 and Fibonacci of 1 is 1. So that still holds true. Now keep in mind, this is technically not going to be, I'll give you the exact term for what it is in a moment, but how we calculate this is essentially, for our display, we display our base cases first. I think I called I called it rich. My rich is my text equals, in this case, I'm just going to type it out because we know the two base cases. So it's base case of 0, base case of 1. And then after that, it is everything that is calculated before we call our function. So the two base cases are the only two things that we normally pre-display, because when we start calculating the function, how the function operates is those values generally never really occur in that sequence unless you give it to the sequence itself, as we are doing down here. Now, we want to calculate Fibonacci. So the first thing you need to do in this situation is we need to test our base case. So now Fibonacci has two base cases, x equals 0, y equals 1. So if we go from the back to the front, we need to test whether those two terms are reached. But in this case, we want to see when we reach the maximum value. So our maximum value in this case is when we reach the last term. So when max is less than or equal to a specific term, now I'm just going to leave this like that for a moment, then we want to do the following. So if we reach that maximum term, then we are done. You all agree with me. We don't want to increase, we don't want to continue with the sequence, we want to stop. Okay. Else, we want to continue with our sequence. Now, in this case, I'm just going to swap it around for the simple reason, when there is no more increasing term, I don't want to output a value anymore. Or I guess we can, for the final output, display text editor, which would be plus minus C string, our value. Now, why I'm leaving this empty for a moment is because I want you guys to think about this. We've got term X, we've got term Y. If you think in terms of the Fibonacci code, you will have 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on and so forth. So, base case 0, base case 1, and it will increase from there on. So when we look at what the values are given to us, we want to test whether the maximum value has been reached. So will that maximum value be variable X or variable Y? Okay, why variable Y? Why variable Y? You can tell me. Yes, because Y is going to be greater than our X, and because in how we calculate the Fibonacci sequence, it is sequence 1 or value 1 plus value 2 that will give us value 3. So value 2 would be the larger value of the two sequences, and value 3 would be the newly created sequence, or the newly created value. So in terms of how we pass that along, I've got a temporary variable that I'm declaring over here, and I'm creating this variable to have X plus Y. So that would be the next term in the sequence, which means that when we call the Fibonacci sequence, or when we call the recursive function to calculate the next one, X will now be, so where X0 was our first term and Y was our second term, X will now be our 1, and Y will now be our newly created value. So Y is our new X, and so sorry, for our next sequence, we're basically just going 1 up. So X will be our old Y, Y will be our new value that we created, and our max value is still the value that we want to test. Now, where do we output our value? Do we output the value over here and have a final output up there? Or do we output the temp value before we call the next sequence? What do you guys think? The temp value. Now, if you're not sure, test it out and see if it works. So let's run this and see what happens. So right now what's happening is you're passing along base case 1 and base case 2 to our formula or to our subroutine. So we output 0 and 1 before we start our subroutine. When we jump into our subroutine, we're calculating the next term and then sending the previous second term as our new first, the second term that was created, and then the max value we want to reach. So let's add this to our sequence and see what happens. Now, keep in mind, this might take some testing. So for now, I'm just going to output the y value over here. And then we'll see what happens. Now keep in mind, we know what the sequence is. The sequence is 0, 1, 1, 2. So let's start and see what happens. We've got 0, 1, and nothing else. And the reason for the nothing else is because I did not know what max value is. So let's go and calculate this until the max value of, let's say, 4. Because we know we'll have 0, 1, 1, 2, 3, and it should be 5 after that. So it should stop until it reaches 3. So it stops when it reaches 3, but what do we see here? We've got a problem here. We see 0, 1, 1, 1, 2, 3. So there's a problem. Let me what the problem is. You can tell me what the problem is. Yes, aside from the fact that we've got 3 1s, but is it a problem with our formula, or is it just a problem with our output? So what should we be outputting here? No, there's not a problem with the formula. The formula is fine. Consider this. Always think about this carefully. We're outputting value x and value 1, value x and value y already. 0, 1. Then we run or step into our recursive function, and the first thing we output is value y. Now value y is already the given value. It's already a value we've displayed. So what you're essentially doing is you're displaying that value again, which means you're duplicating a value that's already there. So let's replace this with 10, the value we are now creating, and then calculate it from there. Do things will work. Would that be correct now? Who wants to take a guess? Will this give me the correct output? Okay. So why is it not going to give me the correct output? What's wrong with the output now? Now we're getting the one term after we've calculated, which means we're getting the value just after the sequence we want. So let's say we know 32 was 34 was there. So let's go 35. Should stop at 34, but it goes one further. What's the issue now? The issue is where we test our max value. So max is being tested only with the y value once you step into the next sequence. So this is a balance of where you want to display it and where you don't want to display it. You'll always need to be very careful of how you test this value. So you can either test it before stepping in, as we did over here, or you can test it after you've calculated the value, essentially. So you can take that value. Sorry, let me just do that. And take that value, calculate it beforehand, see whether temp is a max or not. See whether our temp is larger than our max or not. And then if max is smaller or equal to our temp, then essentially we are done. You just finish. And if it's not done yet, then you can output that value and call the function again to continue this loop until you reach the maximum value. Now, the other way that you can do this, the other way I would have done this, instead of doing an if max is less than or equal to temp, I would have done if max is larger than or equal to temp and then place that in there, because essentially you've got empty code here now. You've got a sequence or a function where there's no code in that specific section, which sometimes can be a bit confusing. Just one thing to keep in mind. All right. And then the fun part here is you're testing that maximum value, which means you get the display that you want. And there you have your sequence. That's one way of getting the sequence. And that's using the value itself. Whereas the previous way, we used a term. We calculated it until the nth term based on the formula that was given to us. Will the type be recorded and uploaded on Blackboard? Yes. The tutorial is recorded. Let me just make sure. Yes, it is being recorded. It should be on Blackboard about 5-10 minutes after the session end itself. So it should be online at about 7 o'clock. It should be available for download already. It's normally very fast or very, very quickly available after the session ends. All right. So just to make sure, do you understand what I did there? With us testing maximum value compared to testing the nth term value? The output itself, that can sometimes be tricky. The output, it depends on how you structure your base case and your iterative call or recursive call. That will work. But essentially, all you have to do is just go and test it out. Maybe put a message box somewhere in between so that you can just test what the values are to see whether you are getting the correct values or to see what values you're getting at what stage. That is the easiest way to determine where your output should be correct or not. But essentially, when creating your base case, always consider whether the base case is determined before or after display as well, if you want to display the value. Now, in this case, we output the sequence. In the previous case, we simply output the value for the nth term. So if I call Fibonacci over there, so what I'm going to do is I don't want to repurpose this. No, okay, let me just. I don't want to show you my code up top for how to. So I'm just going to do this quickly. So in this case, all I want So using the first formula that I showed you, using this function, all I'm going to do is I'm simply going to output the nth term, the value for the nth term. So the value for the 0 term is 0. Value for the Fibonacci of 1 is 1. The value for the Fibonacci of 2 is 1. Fibonacci of 3 is 2. So if you look at what the actual sequence is, you'll see that it starts increasing. So let's look at Fibonacci of 11. So that should be 89. Sorry, I just need to go through all of these. Right. So the Fibonacci of, let's say, 1, 2, 3, 4, 5, 6, 7. So the Fibonacci of 7 should be 13 and be 13. So essentially, we're printing out the nth term, the value of the nth term that we want. So looking at the question, so in the practical, are we supposed to output the sequence or the nth term for the parent question? And if we look at the practical question, it says here, create another button to calculate the parent sequence until the nth term. This must be calculated through a recursive function. Ideally, we actually want you to output the sequence. If you read the instructions, it wants you to output the sequence. But if you only output the nth term, that will also be acceptable. So we're going to leave that up to you. We won't penalize if you only output the nth term, but it's up to you. If you can output the nth term, you can also output the sequence. I mean, consider what I just did here. The nth term of 0 is 0. The nth term of 1 is the next value. 2 is the next value. And if you're kind of following my drift, you can see that I'm kind of outputting the sequence for you just one by one at this time. All right. So the moment you can output the nth term is the moment you can output the entire sequence. It's just a matter of how you format that output. So the first two sequences, once again, it depends on how you calculate it. Based on function, your base cases will still return the values of your base case. Remember, Fibonacci of 0 is 0, and that does return a 0 value. So your base cases will still return those values. So Fibonacci of 0, base case, returns 0. And the other base case, which is Fibonacci of 1, returns a base case of 1. It still returns those values if you call that function. That's why you have the base case. Even with the parent sequence, you can see here, you've got a base case where if n equals 0, if the 0 term is equal to 3, that's your base case. The first term is 1, is 0. That's one of your base cases. And if n equals 2, which is another base case, your term or your value is 2. And anything larger than n equals 2, you have your formula. So we've essentially given you the function, it's just given to you in a mathematical formula. And the so this one has 3 base cases, as you can see. So the nth term for 0, 1, and 2 has been given to you. And then after n is larger than 2, you've got a formula that you need to calculate. But once again, if you call the function of n equals 0 will have a return, which is the return of 3. It's just for the subroutine. So the way in which I did the subroutine, determining the max value, that is where the output starts getting tricky. Because your base case isn't an output anymore. Your base case is now essentially a test to see whether you reached a certain value. So that's why I'm showing you the second way as well in terms of recursion, because this doesn't use the base cases for Fibonacci. This uses a base case that determines whether you reached your final result or the desired result. So always be careful for the difference between the two. Always look at how you approach it and consider what the base case is in terms of how you calculate the function. There's always more than one way to calculate these formulas or to display these formulas, but it depends on how you structured your recursion, what your base case is going to be. For the parent function, personally for me, I would have coded it out in the same way that I coded out the Fibonacci sequence, which means you've got your 2 base cases. So if you call the nth term in this sequence, you will get the value for the nth term. But if you use the Fibonacci, the subroutine that I did, you don't have a return anymore. You essentially have I don't want to say a counter, but you're checking to see whether you reached a certain value, of whether you're still within the range in which you want to continue. In that situation, you need to consider how you display it, where you will potentially display your base cases before you start with your calculations or start with your actual recursive function. But that is something we will address when we look at your code. So based on how you approach the problem, we'll tell you what would have been the best case to do. But for now, it really depends on how you approach the recursive function. Because there's more than one way to approach this recursive function. In fact, there's two more ways in which I can think of approaching the Fibonacci sequence that will all essentially have the same final result, but they calculate it slightly differently. All right. Okay, so I hope that made things slightly clearer. I do recommend that if you did not watch Mr. Cottrell's lecture this morning, he discussed trace tables this morning, which I did not discuss this afternoon. I spent most of my time on the recursive function. If you have not seen the trace table before, please make sure that you go and watch Mr. Cottrell's lecture from this morning for trace tables, or his tutorial for this morning for how to use a trace table. It will be very valuable for you for your first semester test, because you will be expected to essentially use a table. Maybe not display it, but it will be useful to use a trace table to get the result of the question. And he also covers a past paper there, so it's an easy way to see what has been asked in the past as well. Okay, so we still have a few more minutes left. I think we've got about 10 minutes left. I'll be here for the next 10 minutes to answer any questions that you have, but I'm going to stop the recording here. Please note that if you do have any questions, make sure you ask them. You can ask them on Discord. If it's anything prac related, you can put it in the practical question channel. If the assistants are online, you can ask them for any problems you might have. Please note that you do need to show that you've at least attempted the problem. The assistants won't give you the answers. They'll only try and guide you to the correct answers that you will have to create. Keep in mind that they're not going to give you the answers, because if they give you the answers, you will not learn anything from that. All right. But if you have concerns, any questions, any queries regarding anything, you can ask it on the Discord channel. You can email myself or Mr. Cottrell, or you can private message us on Discord as well. Yeah, I hope you guys have a lovely evening further, and we will see you tomorrow during the lecture.